know today and its past are two very different things. More than 4 billion years ago, water flowed across the surface of the red planet, forming the vast river system of the Hoyt's Delta. With a massive ocean covering the northern hemisphere, and even river development comparable to Earth today. A recent study confirmed this when scientists unexpectedly discovered that there is a buried lake beneath the ice at Mars' south pole, stretching up to 30 kilometers in length. According to Time magazine, scientists offer an explanation based on the view that when the planet lost its magnetic field, it lost protection from the solar wind. This constant wind stripped away much of the planet's atmosphere, and the water here also escaped into space as a result. That's only most of it. A little-known fact is that there is a lot of water here, existing as ice hidden deep in Mars. This water is abundant, equivalent to the amount of water in Earth's Greenland ice sheet. For scientists searching day and night for life outside Earth, water is one of the most crucial factors. A recent study in Nature Astronomy indicated that there could be a lake buried beneath the ice at Mars' south pole. With a length of up to 30 kilometers, kept warm by the planet's internal heat. S presence beneath Mars. In 2018, the spacecraft conducted radar scans around the Ultimi Scopuli ice cap area and returned data showing an area with high reflectivity and a frequency consistent with a large amount of liquid water. Such a discovery, beneath an ice sheet on Earth, would be completely normal. The immense weight of thick ice sheets often generates enough pressure to produce heat, leading to melting deep beneath the surface. But there are two problems with the Mars Express discovery. First, the frigid temperatures at Mars' poles should be enough to overwhelm any warming caused by pressure, keeping the ice solid. Second, besides water, other things reflect at similar frequencies, such as metal-bearing minerals and hydrated clays. This suggests the Mars Express findings could also just be an illusion. But Mars Express is not the only Mars satellite to survey the Ultimi Scopuli ice cap. NASA has also conducted similar surveys. During its mission from 1997 to 2006, NASA's Mars Global Surveyor used a laser altimeter. It returned results showing that a 10 to 15 kilometers wide stretch of Ultimi Scopuli has a distinctly undulating surface, with the ice lying 4 meters below the surrounding terrain and rising 7 meters above it. This undulating structure is similar to on Earth, where such phenomena often occur due to upstream and downstream water flow. The question of what is happening beneath the ice at Ultimi Scopuli remains open. But now, an international research team led by geophysicist Neil Arnold from the University of Cambridge, UK, has concluded that there really is a lake at Mars' south pole. This assertion is based on computer models, starting with data sent back by the two aforementioned satellites. They incorporated variables including simulations of subsurface friction caused by ice or water, the theoretical depth variation of the subsurface lake, as well as the historical geothermal heat beneath Mars' surface. No matter how they ran the variables, the most likely scenario the model produced was that there is indeed a lake beneath the Ultimi Scopuli ice cap. A lake kept warm by geothermal heating. The combination of the new topographic evidence, plus our computer modeling results and the radar data, strengthens the possibility of at least one area of liquid water existing deep beneath the ice on Mars, said Arnold. A similar study from researchers at Binghamton University in the US suggests water is trapped within minerals located 29 kilometers beneath Mars' surface. The minerals are a blue-green mineral called smectite, formed from the reaction between rock and water. Smectite is also found on Earth. The team observed ferrous iron smectite on Mars. This is the least thermally stable form of smectite. said David Shaming, professor of geology and environmental studies from Binghamton University. We found that ferrous iron smectite, the least thermally stable form of smectite, is stable at temperatures around 600 degrees Celsius at a depth of 30 kilometers. Clearly, smectite could indeed be a significant reservoir for Mars' missing water. The first evidence of water on Mars was announced by NASA in 2006. Images of two volcanic mountains named Terra Sirenum and Centauri Montes seemed to show the presence of liquid water on Mars at some point between 1999 and 2001. In 2008, NASA's Phoenix Mars lander confirmed the presence of ice on Mars, containing components similar to the water we have on Earth. The red planet has some valleys and ancient channels, where liquid water likely once flowed. NASA's Perseverance rover is currently exploring Jezero crater, a water-filled reservoir about 3.5 billion years ago. It is believed that much of the water that once existed on Mars now exists as ice stored in the polar ice caps and underground. Jenkins said that although this study helps confirm the importance of minerals as a potential water reservoir on Mars, it is certainly not the final word on the topic. The more difficult question about the total amount of minerals in the surface or near-surface environment of Mars has not yet been determined with the necessary accuracy to truly confirm that minerals could be the primary water reservoir on Mars. In the ancient past, water flowed across the surface of Mars. The red planet once had lakes, rivers, streams, and possibly even a vast ocean covering the northern hemisphere. However, the surface water on Mars largely disappeared around 3.5 billion years ago. Scientists believe this dramatic climate change occurred after the red planet lost its magnetic field, which had protected Mars' atmosphere from charged particles from the Sun. But according to new research, the reason water disappeared from Mars is that the planet is too small to retain surface water over a long period. Mars' fate was sealed from the very beginning. There may be a size threshold for rocky planets to retain enough water for habitability and plate tectonics, and that threshold is larger than the size of Mars. 20 Martian meteorites representing a large portion of the red planet's composition were examined. Scientists used potassium as a tracer for more volatile elements in compounds like water. They found that Mars lost significantly more volatiles during its formation compared to Earth. Earth is a planet with a mass about 9 times greater than Mars. However, Mars retained volatiles better than the Moon and the 530 kilometers wide asteroid Vesta. Both are much smaller and drier than the red planet. This highlights that there is a limited size range for planets to have just enough, but not too much, water to develop a habitable surface environment. Such studies will assist astronomers in searching for habitable exoplanets. Crushing a rock on Mars reveals clues to life. NASA's Curiosity rover detected a large amount of sulfur, an element extremely rare on Mars, after accidentally crushing a rock on Mars. These yellow crystals had never been discovered on the red planet before. The rover was exploring Getty's Vallis, a channel carved deep into the slope of Mount Sharp in the center of Gale Crater. When it accidentally drove over a small rock, crushing it. When its camera focused on what the rover had run over, scientists discovered strange yellow crystals sparkling within the newly exposed interior of the rock. The crystals in the crushed rock were too small and fragile for the rover to handle properly. But when the robot drilled into another nearby rock, it revealed the crystals were composed of pure sulfur. Sulfur has been detected on Mars before, but only combined with other elements in compounds called sulfates. Until now, pure sulfur, also known as elemental sulfur, had never been found on Mars. Scientists had suspected elemental sulfur might exist somewhere on Mars, but were very surprised to find it inside surface rock. Photos of the surrounding area also showed the ground around these rocks littered with similar yellow fragments. The Curiosity rover, which landed in this area in 2012, has found several other intriguing rocks in and around Getty's Vallis. It has also photographed ripples formed by an ancient lakebed created by Martian water millions of years ago. Not long before, beneath an ancient lakebed on Mars, Curiosity also discovered an Earth-like region containing clear hints of life. A research team led by Dr. Patrick Gazda from the U.S. Los Alamos National Laboratory has detailed the mystery of an unusual discovery by Curiosity. Central to NASA's hunt for life on Mars, it is the discovery of higher than normal levels of manganese oxide in an ancient lakebed within the Gale crater region, a large impact crater on Mars. To date, scientists have been puzzled because known conditions on the red planet do not allow such an environment to exist. In the study recently published in the Journal of Geophysical Research, Planets, the authors discussed how manganese could have been enriched in these lakebed rocks and suggested life might be the only key. The manganese-enriched sedimentary rock explored by the Curiosity rover is a mixture of sand, silt, and clay. This sandstone is more porous, and groundwater could more easily flow through it compared to clay-rich rocks. The researchers examined how manganese could have been enriched in the sandstone. For example, groundwater percolating through sands at the lake shore or a delta estuary. And what oxidizing agent could have caused the manganese to precipitate in the rock? On Earth, manganese becomes enriched thanks to oxygen in the atmosphere, and this process is often accelerated by the presence of bacteria. Earth bacteria can use many oxidation states of manganese as energy for their metabolism. On Mars, we have no evidence of life, and the mechanism for generating oxygen in Mars' ancient atmosphere is also unclear. Therefore, how manganese oxide formed and concentrated here is truly puzzling. Nevertheless, life is the only plausible explanation for that puzzle. Therefore, the presence of manganese and manganese oxides here could be indirect evidence of ancient microorganisms. If similar life once existed on ancient Mars, the increased manganese levels in these lakeshore rocks might have provided a useful energy source for their proliferation and development. In other words, the area NASA is targeting for the Curiosity mission likely once contained a lake with a rich ecosystem billions of years ago. This is not unreasonable, as Mars had not yet become arid, since the planet was also once in the habitable zone of the solar system like Earth. The evidence NASA has found so far indicates that about 3 billion years ago, the planet once had as much water as Earth, but unfortunately it was lost into space.